topic of today is teaching using HPC-UGent. So thanks all for joining. There are a lot of you. I'm really happy with that. So for those of you who have not really heard of us, HPC-UGent is part of central IT departments. We provide centralized scientific computing facilities, services, training, hence we're here, infrastructure, and also support. This for researchers from Ghent University, but also other knowledge institutes in Flanders, also industry, and it doesn't really matter whether you're a researcher or a student, you're always welcome to use our services. Our tasks include user support, training, also infrastructure installation and upkeep. We do some outreach and marketing, not a lot, but we try to do that. And we collaborate with other supercomputing centers. This is the first session of this sort. So train the trainer, how to use HPC-UGent services to teach or to use them in your courses. This is like the executive summary of the presentation I'll give. I'll go into some more details, but this is like the take-home message. You can leave after these 2 slides if you want. If you want to use our infrastructure for teaching, use the web portal. I can definitely recommend doing that. On cluster Donfan, jobs start instantly. There's no real queue. There is lots of scientific software pre-installed already as modules in the various clusters and also on Donfan. On the web portal, it is possible to install or to make custom interactive applications for you. Students can make their own VSC account, or we can also do that for them if you provide us your course ID. Very important, always prepare a plan B. For instance, in case of an unexpected power failure, we're down. Maybe finally, still, if this doesn't tick your boxes, if the portal is not for you, you really need something else. You need a dedicated server. The VSC Tier 1 Cloud is maybe something that you could use. It comes at a higher cost, but it might be interesting for you. I mean, cost, effort. What should you definitely provide us if you want to give a course using HPC-UGent? The start and end date of the hands-on part of your course. We don't really care when you give the theoretical lectures, but if you're going to use our services or infrastructure for a certain period, we'd like to know that. The course ID, because based on that we can pull a lot of information. The VSC accounts of the group moderators, and whether or not you need a customized web portal application. And please do this well in advance, before the start of your course. So think weeks to months. Please don't think days to hours, because that won't work. We have a lot of work to do. Unfortunately. This is weird. Oh, okay. So don't panic. Infrastructure, a short overview of infrastructure that HPC-UGent provides. Bit of theory, sorry. We have the tiering model where the tier 3 is your personal laptop or the laptop of your students. Above that is the tier 2 level where the university provides centralized services for you, cluster. If you go higher up the food chain, you end up with higher and larger and more powerful supercomputers. Weirdly enough, you also get less and less users. So here are the most users in tier 2 and tier 3. Everyone has a laptop nowadays. Our task is to provide services so that most people jump to tier 2 to offload the compute power from the laptop. And you can go on into the tier 1 level. My team also manages the tier 1 supercomputer Hortense, which is here in the data center. We manage some data aspects, of course. And we also manage the tier 1 cloud infrastructure, which you can also use. I mentioned it earlier as well. but I wouldn't recommend it as a first shot, to be honest. So for teaching, I would recommend using the tier 2 infrastructure. It may be possible also in tier 1, but well, tier 2 is probably better suited for that. If you want to have an overview of all the clusters, of all the infrastructure that's available, just check out that website. Currently we have 8 clusters, and we invest like every 1 to 2 years, we invest between 1 million and 2 million euros in new infrastructure. So we try and keep the infrastructure on par of what is needed and what is used. Currently we have 8 clusters. Those involve CPU-only batch clusters, CPU-only compute clusters, GPU clusters, and also CPU-only. That's actually incorrect. It's recently also CPU also has a GPU, interactive and debug clusters. These all run Red Hat Linux as an operating system. So yeah, Windows applications is a problem at the moment. It's free of charge, so there's really no cost attached to this. You can do what you want. For academic researchers. For industry users, it's pay what you use. That means, yeah, you just pay the compute time that you have spent. Typically after a short exploratory period, that's free. Some examples to give you a taste. So we have cluster Dodo, which has, well, 128 worker nodes. In total, something like 12,000 compute cores and 24 terabytes of RAM are available. They're connected via a very expensive high-speed InfiniBand network between the nodes, so they can actually process compute tasks together. And they also have fast access to shared file systems. Another one is a GPU cluster, Axelhor. Only 9 worker nodes, but GPUs are really expensive. So less CPU cores, only 48 per node, but 4 NVIDIA A100 GPUs per node. Also attached to the InfiniBand network and the fast access to the shared file systems. These are like clusters that you would use more for research, where you submit your tasks in a queue that might be only processed after an hour, after 2 hours, but also could be instantly, depending on how high the workload is, how many people are using it. For teaching, this is probably the best choice. So this is interactive cluster Dolifan. It's actually an old cluster that we recycled. So it's not too big, only 16 worker nodes with only 36 CPU cores. Has one shared NVIDIA Ampere A2 GPU, so it's not really a very powerful GPU, but not a GPU nonetheless, and a lot of RAM. Also has access to InfiniBand and the shared file system, but there are strict user limits on this cluster. That means per user, you can have a maximum of 3 jobs running. You can only have 5 jobs in the queue, and 8 cores can be in use at a time. So you can't use more than 8 cores at any given moment. This is the downside. The plus side is that there's really no waiting time for jobs to start. So your job starts, give it a few seconds, they start instantly. How do we do this? We tell the job scheduler that there are not 16 worker nodes in this cluster, but 160 or something, or even thousands. That means the job scheduler will instantly start your job, but if there are many people using the cluster, the job speed will go down. For interactive work, for debugging purposes, this is perfect, because the biggest waiting time is not within the computer, it's typically within the person. You have to think, okay, I have to do this, and then I can go into that one. Let's try this one. You're typing, you're trying something out. Most of the time you're actually spending time waiting yourself or thinking. So this is perfect for that. If it's not, you have to tell us. If you notice that it doesn't work, please tell us, and we can try and prop the cluster up and add more resources behind it. That will take time, but anyhow, do tell us. So far, we haven't had actually any complaints that the system wouldn't work for them. So this is really ideal for debugging, visualization, and also for teaching, in our opinion. Yeah, so this should be, in our opinion, the go-to cluster. If you want to try or teach something in scientific computing, try first on Donfan. Why not? It's there, it's free to use. You don't have to support it or maintain it. You can just use it and try it. But anyhow, if this doesn't work for you, if for some reason Donfan, the resources of Donfan wouldn't suit your needs for your teaching or your exams, it is possible to make a reservation on another cluster. So we can reserve some resources, just stating on cluster Axel, for instance, we can say, okay, for a course you need one node on which 4 students will work. You need that on 2 weeks from now, Monday, from that hour to that hour. You can request that. You can request that on the account page. You can see the web link there. You have to fill in a form, specify when, what resources, and so on, and then we process them. Please note that these reservations currently still require manual intervention by my team. So it takes some time to process them. So again, please issue them well in advance. Again, think weeks to months, not days to hours. But that's also a possibility. So if Donfan doesn't suit your needs, maybe try a reservation. And then a very important one, this is a disclaimer. Unfortunately, there's no such thing as an optimal system. So using the infrastructure is definitely possible, and I can definitely recommend it. But you have to caution, we cannot guarantee that the system is up at any given moment. We can't guarantee it. The systems are not behind an uninterruptible power source, or not behind a generator. So if the power goes down, the system is down. Yeah. But also sometimes accidents happen, software accidents. Sometimes it happens that configuration error leads to an extended downtime. And it's possible. Our uptime, I think our uptime for tier 2 at least, is pretty okay. We abide by the so-called sperperiode rules, which means that during exam periods we don't do interventions or we don't plan maintenance. Anyhow, sometimes during sperperiodes incidents can happen. For instance, on 16th of June, so very short-lived memory, there was a power outage. It's bad luck, but yeah, can't do without it. In 2022, I also want to mention that there was an extended maintenance window which lasted over 14 days, which was very long in my opinion. That sometimes happens, but not often. Extended outage, maybe every 3 to 4 years, that happens. Power outages sometimes do happen. So think of a plan B. Accept that, yeah, sometimes things don't go as planned. Make sure you have a backup plan at hand. That can be postponing your course, maybe to another week. Running on other infrastructure or having a different examination or course schedule altogether. I can advise, and this is from first-hand experience, a formula for teaching and for exams is longer-term project work. The infrastructure is ideally suited for that. You give exercises or you give a project to students and let them finish it in their own tempo. And of course, give them some encouragement, because typically students only wake up 2 days before the deadline. How do you get access? How do students get access to the infrastructure? So you need a so-called VSC account. The rules and how to request it are mentioned above on that web link. But it's important to notice that all UGent staff and students can request a VSC account, and it's very easy. So it takes literally 30 seconds, point and click. You have to log in with your UGent account, you have to request something, and that's it. And then you have a VSC ID, so you get a number with which you can actually use all the HPC infrastructure throughout the Flemish Supercomputing Center. So that's not only the infrastructure here at Ghent University. In principle, you could also use the infrastructure at Brussels, KU Leuven, Antwerp. This is a relatively new development, so maybe some of you who have had experience with HPC before, for them this might be new. So it's no longer needed to have an SSH key attached to your VSC account. That's really not the case. So in principle, we can create a token, so-called token based on your UGent ID, and that's it. Of course, then you can't use SSH as an interaction path. But that's not a problem because we have the web portal. And I dare to think that most students actually would prefer the web portal. You have the account page, account@vscentrum.be, where you can manage your own VSC account. You can join, leave user groups. You can sort storage usage. You can request more storage quota. You can manage a virtual organization. And maybe running a bit ahead, but you can create groups, and you can also manage groups, even groups we make for you. Because if you're a trainer, you would use the system. Probably at some point you would make a group which contains your students. You would be the manager. This would be where you can do that account management. But as I mentioned, students can, students and researchers can make a VSC ID by themselves. It's always possible. But for a course, we are happy to offload that work from you. In the past, we've noticed a lot of teachers that had to send mails and alert their students, please make a VSC ID, please do it, and so on. We can actually just make the VSC IDs for you, based on the UGent IDs of all the students in your course. So provide us information, again, well in advance, the start and the end date of your hands-on course, your UGent course ID, and who should be the moderator of that group. So the VSC IDs of the people that should moderate and own that teacher's group. And based on the course ID, we will just look up who are all the students, and we will hand out VSC accounts to all the students. It will be, of course, an account without an SSH key, because that's personal, but they can just log in with their UGent credentials. This sounds, I know this sounds at the moment quite theoretical. I'll show it in a minute how that pans out in practice. So we offload the account management to some extent. We make a dedicated group for your course. We assign the moderators that you have chosen to the group, so you don't actually have to make the group. We make it for you, and we create the VSC accounts. And to some extent, actually, we would prefer to have one group per course. This at least would give us some insight into how many courses, how many people are using the HPC infrastructure for courses. And it would also help us, to mind that, how do I phrase it? To mind that there are courses running. So if we know this group, from this period to that period, people are using the infrastructure for a course, we will make special attention. That means, for instance, if there's even a minor intervention that's needed, for which we would sometimes just say, okay, we have to do it sometimes. We will bug researchers, but if you know there's a course ongoing, we might just consider, okay, look, we'll maybe extend, we'll postpone it with 3 hours or something. Can't guarantee it again, but we like to know. So information is crucial for us. Yeah, Software is also an important topic. This keeps on growing. So the first question a researcher or a student will ask, or you as a teacher will ask, is the software that I want to use available on the HPC? I can only state that a lot of software is currently already pre-installed, available through, for instance, the module system. If you include all our Perl and Python extensions, different versions and builds, we support more than 6,000 different software versions. That's an insane amount of software. And this is not only in Ghent, but it's also across the world. We see an insane rise of software packages that's actually pretty difficult to maintain. But we try our best. We try and maintain these. There are more than 200 GPU software packages and versions available. And you can get an easy list using a command like module avail. You can see in a terminal, you can see which software is available at tier 2. What is also possible in the web portal is to have an interactive application. So we currently have some popular generic applications already available, Jupyter Notebooks, RStudio. There are other applications that we can also install. But it's also possible for your course to create a customized interactive application. What does that mean? Imagine you have students on which you really do not want to spend time learning them how the generic system works. You don't have the stamina, you don't have the time, or there's a mismatch with the skills of the students, for instance. Then we can create a customized application where the students just have to select in the pull-down menu, not Jupyter Notebook, but course multimedia or something. I have no clue. The name of your course. What will then happen? The desktop will open up with all settings preset for the students. So you really offload part of informing the students how the system works, which settings they should select. You offload that. So that's the real benefit. Students make less mistakes and you don't have a slowdown in your course. And we do that by locking down options and making them pre-filled. Of course, the downside of this, if your student then goes on and does another course where maybe that application is not used, or just that student wants to use the system in his master or bachelor, how do you call it? Master thesis, for instance, that person doesn't know how to use the generic web interface. So it's possible. Again, it takes time, but it is possible. And we have used it to some extent this year, actually. This application is typically removed at the end of the course. As I mentioned, this is the installation of scientific software is a tremendous problem. It's becoming really an ever-growing tremendous problem for researchers and also HPC sites around the world. We try to bypass or live with it by investing in collaborative initiatives to share build recipes. So other centers, HPC centers and researchers can also reuse what we do and vice versa. So we have easy builds, easy and multi-scale European projects which we're currently involved in. Our vision on scientific software at HPC-UGent is, for the time being, still we provide central software installation as a service. So we like to have you as a researcher, as a teacher, that you don't have to spend time in compiling or choosing the best possible options for your software to have it run on the HPC system. We try to do that as much and as swiftly as possible, but there's a disclaimer in the next slide, unfortunately. So you can save time, you can focus on your research and your teaching. What are current limitations? Windows software. That's maybe the biggest limitation. Windows software on the HPC platform is a big problem. You can't really run that. or we have to do, sometimes trickery is possible, but yeah, consider it almost impossible. So if you are using Windows, if you really need to have a Windows software, we could recommend you to consider Linux or open source alternatives. Or maybe this is something you could try on the VST-T1 cloud. The downside is, of course, that then the management of that is in your lab. Licensed software on HPC-UGent is possible, but we work with a bring your own license model. That means except when there's a license from Ghent University available, we don't ever pay the license fee for you. Yeah, that's just, but you can bring your own license and we can definitely help you install it. Yeah, this is the big disclaimer. We invest a lot of time and effort in this, and it's growing. Currently, we invest 3 dedicated staff that focus mainly on scientific software installation. On top of that, we have three regular consultants that we also pay to get software installed. Other staff is also chipping in, but still we're struggling. It's a massive load, I have to state. So you can see the bar graph on the left. So from 2018, we had something like 250 installation requests. It's growing. In 2022, so last year, we had more than 350 requests. That's a lot, and actually we have attained the level of, we almost attained the level of 2019, end of May this year. So there's a massive request for installation of software, and we're really coping badly, to be honest. So we're struggling. We try our best, but it takes time. It really takes a lot of time before the software is available. So if you want to request software, feel free, please do it. If you really need it, please do it. But please also do it well in advance and have some patience. And also, this is quite important, please use it afterwards. So if you just want to try out some software, just tell us that you just want to try out something, because that will shift our priority level. But if you really need it, we need to know that. User support and training, in a nutshell, this is more like if you want to know more how to use the HPC in the most optimal way, or how to use our systems. We have a renewed documentation available, so docs.hpc.ugent.be, more handy than the previous PDF document. There's also typically, every year we have 1 or 2 introductory trainings, and we also record those sessions. So if you couldn't make it, or it's already passed, you can still check out introductory training. Of course, all the course material is available there. Finally, never ever hesitate to ask us a mail, hpc@ugent.be. Ask us your questions. If you have a problem, just tell us. Again, we'll try to do our best to respond as quickly and as properly as possible. How do you use our systems? And this is a pretty scary diagram. So generically, so this is a bit popping up the hood. How does the HPC system work? You as a researcher or teacher or your students, they connect via a laptop or a desktop to what is known as the login nodes. Login nodes are like the front, the service that really you interface with most. You do that either in a terminal, so via SSH protocol, so you type commands, or you can also use the web portal. And I'll give a demo of the web portal in a few minutes. But then you end up in the login nodes. On the login node, you formulate your computational task that you want to do. You wrap that inside a so-called job. And that job then gets sent on to the compute nodes, who execute your computational tasks. They interface with the file systems, and at some point your computational task is done and you get a message of that. So this is somewhat more in detail. So you connect to the login nodes via SSH or web portal. Even in the web portal, but you don't really see it, your computational task is wrapped in a job script. The job script specifies the resources, so how many cores, how much memory, how long your job will take, which software you will use, what the software should do. This is wrapped, sent on to the job scheduler, which gives you a priority queue. And the job scheduler says at some point, okay, there's resources available, this job can run. This is the generic flow behind it. So if you look at the web portal, there will be an interface document, so like a web form, which you have to fill in. It contains the same information. But I have to admit, in the web portal, it's easier. It's less prone to make mistakes, and you really get asked, this is the information you should provide. You can also hide this complexity in interactive application. That's also possible. Quite important also to keep in mind, the maximal wall clock time of any job is 3 days. So jobs can run no longer than 3 days. That means if you start a computational task today, 3 days from now it will stop. Even if the computational task is not finished, our system will just say, stop. Why is this? This permits us to bring down the machine in 3 days without bugging you too much. It also forces you to make regular backups and of your work. So this sounds complicated, probably. Yep, shoot.
So what do you do then if you have a job that takes more than a week? You can't do it then?
If you have a job that takes more than 3 days, you have to split it up in 2 parts, for instance. Okay. Yeah, depends a bit on what kind of computational task you're doing, but
you have to write your data and then restart.
Yes. Yeah. So I actually write a checkpoint and do that regularly. And this is the benefit. If an unexpected power failure happens, all jobs crash. If you have checkpoints, if you do regular checkpointing within your software, you can restart from probably maybe an hour before the power failure happens. So you don't lose the entire job. But checkpointing is the way to go. There are some pointers in the introductory training on that. And you can feel free to ask me questions later on that. So demo time. The web portal, what I will do is connect in a browser to the web portal. I'll show you the full Monty, so I haven't really logged in today. That means you will see all the hoops I have to jump through to get logged in. But this is also the maximum complexity that people will actually experience. Do some drag and drop file access. Show you that you can even do the terminal shell in a browser, so how to submit a job there, and then demo some Jupyter Notebook, interactive application, and also the GUI. I'll have to briefly jump to another application. 1 second. Okay, so this is a browser. I just type login.hpc-ugent.be in the top window, and this is actually interfacing with the account page. I have to select the institute which I belong to, which is Ghent University. Confirm, and here comes the sign-in from Ghent University. We have multi-factor authentication at Ghent University, so I have to open up the app. I have to state that I'm okay with my name being sent to the account page application, which is just what's it called, RDM specification. And that's actually it. Now I'm logged in on the login nodes in my browser. So what do you see? for those of you who have ever done this within an SSH shell, this looks familiar. So you see a non-graphical overview of all the clusters there, Swallowed, Skitty, Vikini, and so on. How many nodes there are, how many full nodes, free partial nodes, and so on, how many jobs are queued. But at the top panel, there's some nifty information. Remember, I'm just using a browser, so this should work in most browsers. I'm currently using Firefox, but Chrome, even Safari works, Microsoft Edge, I don't know what other browsers are out there, but they should all work. If they don't, please tell us. You can do file browsing, just to give you an idea. You can see my mess in my data folder. You can, you have a graphical way of looking at your files. You can even view and edit the text file, also in the browser. So a new window opens, I can edit here stuff and do save. This is all very straightforward, so you don't have to really upload, download files anymore. It's quite nifty. There are, if you want, you can even view images. I mean, anything's possible almost in this interface. You can also drag and drop files. So, one sec, I have to share my entire window. Yep. So this is, for instance, something in some folder I have. I can just drag and drop it and upload it and download it. Same way as you would interface with, for instance, Dropbox. So this is the file browser. You have many different, all the different main partitions that there are per user are listed here. So that's in a nutshell what you can do with the files. There's a job composer. I have no clue how to do that, how to use it. What I prefer still doing is using this login shell access, where you can get a Linux interface, and you can type typical Linux commands like ls or qstats or top or whatever you want to do. So if you teach Linux, for instance, if you want to teach Linux to students, you just want to have access to a Linux box, this would be it. Remember, you're working here on the login nodes. So no heavy lifting, no heavy compute stuff here, please. That would be a bad idea. If you want to do compute heavy stuff, I could recommend another interactive application here called Shell Tmux. This will also show you the generic interface, the job schedule actually, a part of the web portal. So if I launch the interactive Shell Tmux session, what is the purpose of this? I want to start a shell, but I don't want to, so a Linux shell, but I don't want to start it on the login nodes. I want to start it on a worker node. To do that, I have to tell the job scheduler, look, I want to start a job on a certain worker node. Please give me one core on one worker node. This is the form that we will now fill in. You have to select a cluster. As you can see, you can select any cluster you want, but for the teaching purposes, I would recommend Donfan because my job will start instantly. I make an estimate of how many hours I will work. This is a Hello World example. I'm just going to use 1 hour. If your teaching class takes 3 hours, I would recommend maybe having that job run for 4 hours. Remember, if the hour is up, job is killed. So quite important. I'm just going to use one node and just going to use one CPU core. If I want, I can immediately type some extra sbatch arguments, but I don't want to do that. And I'm now clicking launch, and it now will take a couple of seconds. What happens in the background? This form is written inside, is made like a job script. This job script is packed, sent off to the job scheduler. The job scheduler is now trying to find an empty core on Donfan for me. and look, it says your session is ready, you can connect. If I can connect, a new session opens, and what happens? You still see a Linux terminal, but now you notice it on node 4010, so it's no longer the login node, it's a dedicated node and core for me on cluster Donfan. That's it in a nutshell. I can disconnect. I can delete this session. So this would be interesting if you give a Linux course, or you want to just take something, you want to show some bioinformatics tools where you want your students really to interact with the Linux interface. Yep, shoot.
Is it the same as an interactive session where you would like install software on a specific node when you use this, or is it different? On a specific cluster, I mean.
Yeah, I can do the same thing on an other cluster. I can show you. So if I pick Doduo, do the same thing. Same workflow.
Like if I want to compile something for a specific cluster, I could use this.
Yeah, you could do. Yeah, that would be an optimal way to do it, indeed. Yeah, yeah. The only downside is, of course, Cluster Doduo doesn't have the guarantee that your jobs start instantly. So if it's really busy, it could take a couple of minutes. But just if typically for compilation, you don't require too much resources, so the jobs typically start quite swiftly. In this case, it takes it's actually starting, but it takes a couple of seconds yet before my session will appear. So this is for more in-depth Linux applications or Linux savvy students. But what about students that you want to learn how to program in Python or R and don't really want to torture with the Linux interface? There are, for instance, Jupyter IPython notebooks as an application here also available. So it's the same interface. You see a pattern emerging here. Again, I have to specify what resources, which cluster I want to use, how much time I'm going to use it. I'm going to do Donfan again, just 1 hour, 1 node. I can select a specific IPython version if I apparently want to. To be frank, I have no clue how IPython works, but I can demo it. You just, again, click launch, and you wait a couple of seconds, and your IPython notebook session will start. The Dodo teamwork session, in the meantime, has landed. As you can see, I'm just going to kill it so that the resources are freed up. In the meantime, we wait for the IPython notebook to run. Other interactive applications in this same respect is RStudio Server. I really have no clue how RStudio works, but I'm told that it's similar. So here you can connect to Jupyter Notebook, and this is allegedly the Jupyter interface, and this is the only thing I can do. Launch a new notebook, and then do something like and that should allegedly work. Hey, IPython, it's there. You can use it. There's no need to set up your own IPython server or whatsoever. Please use it because it's there. It's no effort to use it. Other interactive applications. Imagine you have a. This is more like. Imagine you teach your students computational fluid dynamics. You teach them how to use some kind of scientific software to do CFD, and at some point you want to look at your results in a graphical way. I've known a time where you had to then download all your results to a laptop, do it there, and visualize it, and so on. in this respect, it's no longer needed. You can launch a so-called cluster desktop. What is this? You can request a dedicated worker node that does some heavy lifting for you. So you really end up with your own private mini cluster that you can use for a couple of hours or days, where you want to run some interactive analysis. And the GUI, so graphical elements, are also streamed over the internet, all within your browser. So again, you don't need any helper applications on your laptop. This is the same interface again. So I'm again selecting cluster Donfan, just 1 hour, 1 node, 1 core. And here I'm already giving it some auto start parameters. So what I will end up with is a Linux desktop that runs, on which I can run specific commands. I'm already giving it 2 commands, module load paraview and then execute paraview, which means module load paraview, load in the paraview software environment for me, and then run the paraview application for me. So as soon as I click launch and then connect, you will see a Linux desktop appear, and I have to be quick, but then at some point paraview will open, in which you can do some GUI stuff if you want. For some reason it's a bit slower. I hope nothing's, yeah, shoot.
Can you do this auto start also for a whole group of students? Like if you have this group in your class and all the students need to use the same modules? That's what I experienced actually last year in your desk, that there was continuously this trouble with this module load, and they loaded the wrong modules and the wrong version.
There's 2 ways around this. Either you give them information, you have to load in this software, you have to do this, and then they have to copy paste in the right way. Errors will still happen, pretty sure. But then at least they know how this interface works. The other way around that is, in principle, we can make a custom application. So this is like another separate checkbox that will appear here, that also even will only appear for the students of your course. They click on that, and for instance, all those module load commands are instantly automatically preset for them. Can they then still change that? Yeah, probably. No system is student-proof, but you can offload that. That's that problem. The downside is, of course, they don't see the interface. But we can't really, every student still has to launch their own session. We can't really do that for them. So at some point they will have to interface, select a menu from the drop-down menu and actually select it. So in the meantime, my cluster desktop is ready. You had a question. I'm going to do that in a minute. And what you can see here instantly is paraview, which has loaded in the meantime. For those of you who know Linux a bit, you here see the typical, atypical Linux interface. So if you want, you can knock yourselves out and start a web browser in a web browser, or other applications that are available in Linux. You have a terminal here as well. Again, this is working on node 4011 of Donfan, so this is not the login nodes. But the purpose of this application specifically, you don't see it too big. Anyway, this is a graphical user interface where you can do interactive stuff. You can show you can show graphical elements. It's no longer text-based. You can actually do other things. I don't know if you see it in the bottom left. You can just see X, Y, Z axis turning. Other stuff is possible with the GUI. You had a question first.
Yeah. Now you're showing an example with paraview, which is already installed. So how does this work with licensed software? How
so
do this?
We can install licensed software if it's Linux capable.
Yes.
we can get it installed, and then we make a connection to typically a license server. That has happened in the past, and that works. We still have to, it takes time, of course, but it's possible.
Yeah. And is it then possible for multiple users to use the same license, or is it?
It depends on your license.
Yeah, okay.
It really, yeah.
It's a personal license.
Personal license would be a problem. It depends on how the license is configured. If your course previously was, we have a license for one workstation on which 1 or 2 students can work, yeah, we can't change that. We can't change it in a virtualized environment where you can suddenly work on that one laptop with 40 people. That's impossible. But if you do have license seats, and check, because sometimes vendors do have some limited license model at a even small costs, sometimes even free, where you can use it for like 10, 20 students. But that really depends on the software.
So we have two kinds of software. So the one is software where we are allowed to install it on 3 different machines, but only one user at a time.
Yeah.
But we tend to use it for different users. So now we install it usually on a local computer, but that's not always easy. It cannot be accessed from home, for instance. But the idea is to install it on a cluster.
Yeah, it's difficult to state France. We have to read the license.
Okay.
We check whether we can legally do it. And sometimes it does work, even with a limited allowed number of users. But sometimes also it doesn't work. It depends software to software.
And the software then gets installed in the central system
Yeah.
within our view.
Yeah. Or in a group. Also wanted to state, you don't necessarily have to use centrally installed software. If you want, you can install software yourself in your own directory. But if you're working with students, you don't want to torture your students with, look, this is the first hour we're going to spend how to install a software in your directory. Unless, of course, you think that's part of the learning experience. I have no problem with that. And sometimes in certain courses that is exactly the point. You can still do that. But we can, we're happy to try and offload that part also from you and get the software installed so you can just use it in the module. There was another question here.
So now, with the screen it runs, you want to that like if you're from home and you have very big CSV file, how does it compare?
It depends on your internet connection. Yeah, that's, yeah. And this is all fiber. And then there's Wi-Fi, for a lot of people here. Probably also using Wi-Fi. Don't know if someone is streaming something. That causes a burden on the Wi-Fi, and network connection is difficult to predict when it will work. But try it. Usually you don't get any big problems. But yeah, of course, if you have very heavy CSV files, maybe the system would fail. I would love to see though that it gets clunky. That would be interesting. You can always still, of course, download your software. Yeah. Download your data file. Use Globus, by the way, for that. That's way more interesting.
So when the data file is ready, it's being sent to your node again, or is it still going?
No. So this is here. So you interface with the login node. You make a job. You do some computational task. The computational task is executed on the compute nodes, but you actually still use the shared file system. Well, okay. In principle, you could also use the local file system of a compute node, but I would check out the introductory training for more information on that, but typically you use the shared file system. For instance, you do your calculation on the Scratch file system, which is optimized for I/O. Maybe you then copy select the files as part of your JavaScript to the data, but you can also leave it there, or you can instantly work on the data, although I would not recommend that. But this is shared, so this file system is shared with all the worker nodes, also with the login nodes. So actually your data would remain where it was. It would just be, you would just approach that data from the login nodes or from somewhere else. Don't know if that was clear. Did I forget to demo something else? This is the GUI. I don't think so. This is like the. In a couple of minutes, I really want to hear your questions or more about the things you would like to do. But I briefly want to finish the presentation. So I think I did everything. Yep. Going back to VSC infrastructure. So what if this is not for you? So if you notice, look, this portal thing, no, it doesn't work for me. I need dedicated resources. I need a dedicated server which I want to use. Please do me a favor. Before you go and buy stuff, check out this first. The Tier 1 Cloud, or maybe even Tier 1 Compute, but definitely check out Tier 1 Cloud. What is this? So this is an OpenStack platform that we maintain. It contains a video that shouldn't be there. It contains hypervisors with UPS functionality, so they keep on running even when the power goes down. We have CPU hypervisors with somewhat older hardware, but it works nevertheless. We also have GPU hypervisors. So it's Red Hat OpenStack. It's and main importance, it's supported by our team. So that means you don't have to do the work to maintain your software. You mean to maintain? I mean the server. What is this? Yeah, sorry for that. So it's maintained by us, the infrastructure. What is not maintained by us is installation of what you want to specifically do on that server. The software you want to specifically run on that server. The user management that you want to execute on that server. That's something we don't do. You have to do that. So do I recommend this for teaching? No, not at first sight. Definitely first try the web portal, please. Do yourself a favor, try out the web portal. But if you really notice, look, the web portal doesn't cut it, before you buy hardware, which you will always have to maintain yourself anyway, which you have to power, you have to replace hardware and so on. Try out this platform. It's there for power users, so it's more niche, but it's project-based, so it's free of charge. Starting grants are continuously open. The acceptance rate is 99.99999%, and you can even submit larger projects, and we're happy to help you with that. So. But please remember, first portal, please. Try out the portal. If that doesn't work, we can try it. And I would be really happy to hear from you. Are there certain things you're worried about, questions, shortcomings you see?